Alright, we're going to finish up our unit on Introduction to Geometry with the distance formula. So the distance formula, the goal is to come up with a method that will enable you to find the distance between 2 points. So this is very useful because on maps you can get latitude and longitude, and you can find distances using this concept. So let's try to develop a method for doing this, just using our intuition first, and we'll come up with a formula later on. So how far apart are the 2 points, -2, 4, and 4, 12? First, let's draw a little graph. Not very neat, but it will get the job done. So -2 up 4 is right there, and 412 over 1, 2, 3, 4 up. Well, if that's 4, then I'm going to go 5, 6, 7, 8, 9, 10, 11, 12. Uh-oh, it's way up here, right? So the other point, sorry, I'm kind of going too high here. Here and here. So the task is to figure out how far apart these 2 points are. Well, that's a diagonal line, yeah? And, you know, you could lay a string down on it, you could try to do some kind of tricks or something like that, but considering we've just learned the Pythagorean Theorem, it might be nice to try to use that information to help us figure out this distance. So we can do that by breaking this into its 2 components. And by components I mean looking at the horizontal distance sideways and the vertical distance upward. Okay, so if we started here at -2 and we ended here at 4, instead of traveling along this angled path, we could have walked horizontally this far from -2 over to 4, which is a distance of 6. Then we could have turned, could have made a right-hand turn, and we could have walked from here, which is at +4, up to here, which is at +12, which is a distance of 8. Okay, and that would take us from the same starting point to the same ending point. So obviously we had to walk farther. If we walk this way and this way, that's a distance of 14. So this has to be less than 14. But we have a triangle here in which we know the 2 legs and we have a right angle, which is perfectly set up for the Pythagorean Theorem. So remember, that's a squared plus b squared equals c squared, and the hypotenuse is the c value, and your 2 legs are your a and your b value. So we can plug these numbers in here. 6 squared plus 8 squared equals c squared. 6 squared is 36. 8 squared is 64. 36 plus 64 happens to be 100. And the square root of both sides gives you 10 as the distance. Or, well, it gives you c, which is the distance between these 2. So by using that as an idea, we can develop kind of a formulaic method to solving this equation. Alright, but the idea always comes down to that you're using Pythagorean Theorem. So if you forget the distance formula, just draw a triangle in there, find the length of the horizontal distance and the length of the vertical distance, and you can solve it that way. So here's the steps formalized. Graph the 2 points and create a right triangle. Okay, we did that. Find the horizontal and vertical changes to label the legs of the triangle, and then set up the Pythagorean Theorem to find the hypotenuse. Now, it's kind of tedious to graph the points and draw the actual triangle. So once you've done this a few times and you're getting comfortable with it, you can skip the actual graphing and just find the change in x, which we call delta x, which is x2 minus x1, and the change in y, which we call delta y, which is y2 minus y1. Let me go back a slide. For example, we started at -2 and we ended at 4. That was a total distance of 6. The way that we got that was 4 minus a -2, right? Which is 6. So this is our x2 minus our x1, which is that. So our delta x was 6. Okay? So if we do that, then our triangle, this side becomes delta x, this side becomes delta y, and this side becomes d. Okay? And delta y is y2 minus y1, and delta x is x2 minus x1. Okay, now if we plug all this into the Pythagorean Theorem, we get a squared plus b squared equals c squared. So our a value, we can write x2 minus x1 squared, plus the b value is right here, y2 minus y1 squared equals c squared. Now, instead of writing squared here, I'm going to take the square root of both sides, so that squared cancels out. and I can put a square root on right here, and instead of calling it c, I can call it d for the distance. And that, my good friends, is the distance formula. So I hate the distance formula. I hate it, hate it, hate it. And the reason I hate it is because it's very large, and it's very nasty, and it looks complicated, and it's got all these variables and squares and square roots and parentheses and addition and subtraction all mixed up. And it's not that easy to remember for new students. And really, it's really an ugly way of representing something very nice and something very simple, which is the fact that all you really did is you drew a triangle, okay? You found the length of this side, you found the length of this side. Those two lengths are right here, and then you plug that idea into the Pythagorean theorem. Okay, so if you remember the Pythagorean theorem, and you understand how to find the length of these sides by subtracting the two values, the x1 and the x2, or the y1 and the y2, then you absolutely do not need to memorize this as some kind of massive distance formula that you have to memorize in Algebra 1. So I encourage you to steer clear of memorizing it as a formula, and instead try to understand it as an idea. Okay, let's do a couple of examples. Find the distance between each pair of points. 2, 4, it's right here. -6, -2, 2, 4, 6 is right here. Okay, so let's draw a triangle in here. We could count how big this is, but we know we -6 here, and we're 2 right there, so that's a distance of 8. Here we were up 4. Here we're down at -2, so how tall is that? 6. And this right here was 8. So the total has to be 10, because if you remember, this is a 6, 8, 10 triangle, which is a variant of the 3, 4, 5 triangle. So 3, 4, 5 was a special right triangle. If you double the length of all the sides, you get a 6, 8, 10, which is the same thing we just did right here, 6, 8, 10. So I'm not going to go through the math again, because it's the same. How about here? -1, 7, and 6, -2. Let's try this one without actually drawing the picture, just for fun. Our delta x, or one of our legs values, we started at -1, and we ended up at 6. How far away is that? Well, that's 7. How about delta y? We started at 7, and we went down to -2. How far away is that? That's a distance away of 9. Okay, now we use Pythagorean theorem. So we get 7 squared plus 9 squared equals distance squared. 7 squared is 49, plus 9 squared is 81. Okay, if we add 49 and 81, we get 130. Then we take the square root, and we get that the distance equals a square root of 130. Now, if that was simplifiable, we would certainly want to simplify it. But if we factor this out, we get 13 times 5 times 2. And none of all those are prime, right? So there's no perfect squares in there, so it can't really be simplified. So the distance is square root of 130 in radical form. If you wanted to write it in decimal form, you could. It's between 11 and 12. How do I know it's between 11 and 12? 11 squared is 121, and 12 squared is 144. So since 130 is in between these two numbers, its square root has to be in between these two numbers. So it's basically between 11 and 12, maybe 11 and a half, something like that. And now looking at the two side lengths, does that make sense? If you have a 7 and a 9, so if I plot these 2 points, -1, 7, -1 up 7 is right here, and then over 6 down 2 is right here. How far is that? This length is 7, this length is 9, this length is around 11.5. It seems reasonable given the picture and all the ideas. So it's good to check and make sure that your answer kind of makes sense and it's not too long or too short based on the two lengths of your legs. Alright, that's it for this section, and in fact that's it for the unit on Intro to Geometry. I hope that you've found it nice to be able to apply the things you've learned in Algebra 1 to some new ideas in geometry. Let me know if you have any questions in class.